Let's look at some of the most common instrumentation faults in industry as well as how to diagnose and fix them. The faults we are going to look at will be one of the most common type of instrumentation loops you will find across industry, a 4 to 20 milliamp process transmitter. The transmitter could be a temperature, pressure, level or flow instrument. Here's the configuration of the type of loop we'll be fault finding on. The feed transmitter will be connected to the process maybe by a small ball tubing or directly in pipework or a vessel. The two-wire transmitter is going to pass through a local junction box and onto a multi-core back to a marshalling cabinet, likely in an equipment room. In the marshalling cabinet, the loop will have an input isolator barrier and then the loop would be terminated into a PLC input card. The process variable will then be displayed on a HMI or human machine interface that a plant operator will be monitoring. This is fairly representative of what you might think out there on various sites across different industries. The typical 4 to 20 milliampere loop may fail in a few different ways. The common faults the operator may report are: instrument may read higher or lower than the operator expects. The process condition to be of an instrument may fail by going over the 100% range value of the transmitter or under the 0% range. Instrument reading might be frozen over a long period of time, meaning the operator doesn't trust the value that they are reading. Even though there are only different few ways, the transmitter can show that there's an issue to the operator. There are lots of different ways. I'm going to cover some of the most common type of 4 to 20 milliamp failures that are common to an electrical instrument. 1. Unusual process condition. As you will find out as an instrument technician, often a reported instrument failure isn't a failure at all. Unusual process conditions such as higher or lower pressures or level may lead an operator to report it as a failure. You will often test the instrumentation to find it is operating correctly and that the problem is process related. Always try to work with your plant operators to discount any unusual finding conditions that may have led to the perceived fault before diving in with fault finding. Other times, calibration drift of the instrument might be causing the unexpected readings reported by the operator. If this is suspected, then calibrating the equipment will help restore trust in the reading of the instrument again. This is a broad category and will take some investigation and testing. Now, looking far from what we've done, we can say that either the input card or the input isolator might be part of the problem or even the instrument itself that is causing this failure and is also causing an open circuit in your loop. With the multimeter, you can check if there is voltage upstream and downstream of the instrument. If there is no voltage downstream of the input isolator, then this would indicate a problem with the isolator. Replacing this often will remove this problem and bring your process back. The instrument itself could have failed. A good way to test this is to replace the transmitter with a signal generator or to do this with a heart-field communicator. By simulating the 4 to 20 milliampere, the transmitter will be able to tell you if the rest of the loop is operating currently. Your likely problem might be caused by a whole lot of issues depending on the specific instrument you are working on. If you still can't get the expected reading on the HMI, try injecting directly into the input card. If the problem still remains, then either the input card channel or the whole input card could have failed. If this is the case, then an input card replacement may be needed. If injecting into the input card gives you the expected result, there could be an issue with the feed wiring or the input isolator. There are unusual more common ways this can happen in harsh weather conditions and high vibrations. Location cabling might sustain mechanical damage from other works, which also makes this failure more likely. Wiring issues may be loose terminations, especially on higher vibration areas. This could also be a circuit drop or high loop resistance. So using a multimeter, you can test for loop resistance and it's also a good way to notice this fault. Open circuits loop by disconnecting at various places to narrow down the fault wiring issue could be caused by physical damage to the wiring. This can lead to fuses, MCB, or electrical protection issues. A good diagnostic test for this would be to use an insulation resistance tester. This piece of equipment apply a voltage to the course and measure the resistance between the measured conductors. Always be sure you are familiar with the equipment and follow the safety precautions before doing any disconnection. Also disconnect any sensitive equipment such as barriers or instruments before carrying out this kind of test. Block instrument impulse lines. If there is any blockage between the instrument and processes, measuring this could cause flat or delayed readings. Again, this will depend on the type of instrument you are working on, but always keep in mind this failure mode, especially on liquid process, could contain particulars, fuses failures. Most loop provide protection from short circuits or excessive current load with a fuse. The loop fuse is designed to break down and no longer conduct electricity when the current in the loop is above. Once the fuse is blown, this will prevent any current flowing and the loop will show as an open circuit. It's worth noting that fuse failure isn't always the primary failure. The fuse is likely to have failed due to a short circuit or other component readings. You can check the fuse with a multimeter on a resistance settings and ensure the fuse isn't open circuit. No power in the loop. If the local fuse is good, then there could be an issue with power upstream of the local fuse. The input loop may be powered by the PLC input card or some external 24-volt distribution via local MCBS or AC to DC power supply. The power for the loop may have been lost. Check the loop for a suitable voltage, usually 24-volt DC with a multimeter. Check for trip to MCB or power supply status LED. Hopefully, this gives you an insight into some of the most common failure modes you will come across out there in the industry. Can you think of any more? Write down in the comment below some of the issues you might have come across. Thank you. I'm Laura Chinedu.